All right, so let's talk about homework problems. Somebody have these for me? So what's number 5 in 8.5?
Okay, use the equation defining.
So 8.5, number 5 says use the equation.
Defining each function
Okay.
to identify the function as an increasing function, a decreasing function, and a constant function.
Okay, so do they give me a formula?
Yeah.
Okay, so what's the formula?
F of x is minus 2x plus 5.
Okay, so they really want me to classify as increasing, decreasing, or constant, right? Okay, so first, what do I need? Yeah, so I need to know some stuff about the function, right? So when I look at this function, what do we think?
Linear equation of slope?
Yeah, so this is a line, right? It has slope.
That's the y-intercept.
Sorry, I'm thinking about the whole thing.
Oh,
So the slope is
negative.
-2, and the intercept is +5. Do I care about the intercept in terms of increasing or decreasing? No. So this is a line with a negative slope. That means, really, right, that it looks something like this. This line isn't steep enough, right? This line isn't steep enough. But we could adjust. But it looks more or less like this, right? So this is what? Increasing, decreasing, or constant?
Decreasing.
Decreasing. Decreasing. And where is it decreasing? It's decreasing.
From left to right.
Remember, usually there's an interval, right? Yeah, this is decreasing on R. And it's nowhere increasing and nowhere constant.
Okay, I still don't need the all. Oh, there's 3 numbers?
All the numbers.
All of them. So because
Right, another way of writing this would be to write
all numbers are.
minus infinity to infinity.
Okay.
Right, those are the same symbol.
Oh, okay.
Meaning it doesn't.
Well,
change
sorry, they're
direction.
different symbols for the same idea. What's that?
Meaning it doesn't change direction.
Yeah, meaning it's always decreasing, it doesn't change to increasing or change to constant. You guys see that? Okay. You want to try another one? Was there another one there?
I guess try number 9.
Okay, so presumably same instructions.
Yes.
And the function is,
Function is minus 3.
so it's f of x is -3 or something. Some name of x is -3. Okay. What's this thing? Yeah, this is a constant, right? If I was to think about this as a function, I might think of this as a line, right? Slope of 0. Okay, see that? This is really a horizontal line, right? So it looks like this. Oops, it looks like that, except, we'll just do that. Right? So this is my function that I've drawn here. This is f. Cool. So I want to know increasing, decreasing, or constant? It's constant.
Can we say the constant is also when the slope is 0?
Yeah. So a constant function is a line with slope 0. Yeah.
When will line be, oh well, since it's -3, we'll leave the -3 in
So the function value is -3, right?
Yeah.
So this is corresponding to y, is there -3?
Oh, okay.
Did it fool you when I switched my
Yeah.
axes? Sorry. I switched my axes because I realized exactly that same thing, right? I drew the two lines and then I realized, oops, the function's supposed to be below the axis. So then I relabeled the x-axis.
Why would, oh, so why wouldn't it be -3 on the x-axis?
Because this is an output, remember? Right, this is saying the output of this formula, right? The output of this function is -3,
Oh, now
regardless of what the input is. So outputs go on the vertical axis and inputs go on the horizontal axis, right? All right, so this is constant on where? What's your interval?
Nothing?
Oh, you don't have an interval, so it would be infinite.
Yeah, it's constant for R, right? Or it's constant on -infinity to infinity. Where is it decreasing? Yeah, it isn't. Where is it increasing? Yeah, it's also not increasing anymore. Other things?
Number 13?
Okay, what was number 13?
I know, maybe I should.
It's a whole list of them.
Wait, gotta give you something. How was it?
Somebody have it open to that page.
Number 15. Don't listen. This is
Okay. All right, so here's number 13. I'm supposed to find out a whole bunch of information about this picture. And this says, this point is 0, -1. And then there's another point here, which is 2, 0. Oops, and I'm going to put my line through that. Okay, so here's the picture roughly out of your book, and we're supposed to find out basically everything we can about this function. So first they ask for slope. Okay, so can someone tell me what the slope of this is and why?
You go up one in the y-axis and over two in the x-axis.
You guys all see that? It's the rise over the run, right? So in 2 units of run, I rise a unit. So that tells me it's
1 over 2.
rise, right, over run. Cool, so I get 1 over 2. B asks probably for the intercept, right? This is x-intercept. C is y-intercept. Okay, what's the x-intercept?
2, 0.
That's 2, 0. Alternatively, you could write this as or x is 2. I'm okay with that. Okay. How about the y-intercept?
0, -1.
That's at 0, -1, or y equals -1. I'm okay with that phrasing as well. Cool. All right. Part D is going to be equation, domain.
Yay!
Okay, so what's the domain on this one?
Right, R.
R. And which way did you squish things to find that out? Yeah, vertically you squished onto the x-axis, right? So we find out that we get domain of R. How about the range? It's the same. Why? Because we switched the other way. Yeah, you guys playing along with us? Okay. Part F. Determine the values for which the function is positive. So x vals on which positive. Okay, so, yeah, so what's this asking? What do they mean on which the function's positive? They mean they mean where the outputs are positive, right? So I go, okay, outputs are positive when I'm in the top half, right? So that means the outputs are positive on like this piece, and I need the x's that go with that piece, so I think about flattening that out. So I'm looking for 2 to infinity. Because that's all real numbers, and what I want is only half of them, right? I want the half of them right at 2. Okay, so do I close or open the brackets? Which brackets do I close?
Close to.
Okay, so this one at least should be easy, right? This one's got to be open. Why? Because infinity's not on the number line. Okay, now do I close or open the 2? What's the output that goes with 2?
0.
0? Is 0 positive?
No.
I don't know. It depends on your definition. So if you think 0 is positive, you close it, right? If you think 0 is not positive, you leave it open. Does that make sense? This is an area of ambiguity, right? Whether 0 is positive or not. Let's assume it is. Math doesn't break if you assume it's not. All right, part G, determine the x values for which things are negative. Okay, what do I get there? Okay, so we need to make sure things go in order, right? So we do negative infinity to 2, right, the other stuff. And then this one gets an open bracket.
Wait, can you say that again?
So the other stuff, right, that's where I'm looking for where the outputs are negative, right? That's in this half. So, okay, where are the inputs corresponding to negative outputs? Well, they're above this part, right? The x values that go with this stuff. That's these guys. So that's negative infinity up to 2. And then here I get to make a choice again as to whether 0 is negative.
It's optional.
Yeah, so this one can be either open or closed depending on what you feel like, I guess. Depending on the convention that you're using. So I'm going to say that 0 is both positive and negative. This distinction doesn't matter much. I would say that the right answer is 0 is either both positive and negative, or that it's neither positive nor negative. The 0 is positive but not negative is probably not a great choice. Okay. All right, so this I'm not going to count you off for, okay? If I ask for 0, it's kind of ambiguous. Then what? Where is it decreasing and increasing? X values decreasing. Yeah, and x values increasing. All right, where's the x value on which we're decreasing? There aren't any. Why not? Yeah, because the line's increasing, specifically because it has a positive slope everywhere, right? Or we can look at the picture and see that it's pretty clearly increasing, right? So, what do we write here? Yeah, so I would write something like not applicable, or never. Do not write x equals 0 here. Or don't write 0. Why? Because it's not decreasing at 0, right? You guys all see that? You could write there aren't any. That would be fine. Okay. This actually happens so often that we have a symbol for this in math. This little circle with a line through it.
Empty set.
Yeah, this is an empty set. This means that there aren't any things. Okay. You can use this symbol if you want to or not. If you want to totally ignore this symbol, that's fine. You don't have to add this to your brain, okay? Later in life, I would ask that you add this to your brain, but this is not the later class. Cool. This, though, is why I ask engineers not to cross their zeros. Don't cross your zeros. It means something. How about x values increasing? That would be the, not the range, but the domain, right? It would be all the x's.
So it'd be all.
So we might write r. We might write minus infinity to infinity. What else might we write there? Up here we were writing there aren't any, right? So here we might write all real numbers or all the x's even. Cool.
Is the domain is always R?
No, the domain's not always R, remember. We're going to see some more examples of that later today. So there are some times, right, when I can't fit a number into a function. For example, if it requires me to take the square root of a negative number, or like later today, we're going to talk about when it would require division by 0. You guys okay with that? All right. Other things from homework? You guys have any more? Doesn't have to be out of 8.5. This can be other review things. What's that?
So you wrote us back for
What's that?
for the test.
For the
And
test.
it said that some were skim. Yeah, like they weren't as good.
Oh, when I skimmed through the
Oh.
practice sheets, some of them were a little bit shy on material out of 8.5 and 8.4.
Okay.
So if you, since that's the freshest stuff in your head anyway, that's probably the stuff you need to review the least. But do expect a problem out of 8.4 and a problem out of 8.5 on the exam.
So you want us to put all the sheets out?
No, I specifically don't want you to waste paper and print them.
Okay.
But they do give you a good idea of which homework problems or which problems you could try to do
Okay.
to review.
Fine.
So the reason that you got 1 million practice tests is just, if you want to practice and do them all, go for it. If you feel like that's the amount of practice you need, do it. If you feel like you can do 2 of them and be okay with where you're at, that's fine too. Okay? I would recommend that you do at least 2 of them. What's up? Sure. Set another one of these ones, but
Well, it is, but they only give you the equation.
okay, and then they ask for a similar thing.
Yeah, they ask for all that.
Okay. So,
It might be repetitive, but
no, repetitive's good at this point. We're preparing for an exam. I would like it if we could do well on that. So this is number 19. And they tell me that f of x is,
maybe it's 150x, so probably plus 30, 300.
okay. And then they ask for all that stuff.
Yeah, slow.
Okay. All right, so here we have a slightly different problem, right? How could we make this problem into one identical to 13? Yeah, we could graph this, right? If we graphed it, then we'd have a picture, and then we could just do problem 13 too, right? Or our procedure for 13. Okay, so the one formula I would like you to know for this is just to know how to graph a line from looking at the equation, right? So when I look at this, I see, all right, there's this 150 part, and there's this 300 part, right? What do those mean? Yeah, the minus 150 means that for every unit of what, I get what?
For unit one, you went down. Over, that way.
Yeah, so what I'm thinking here is I'm thinking minus 150 over 1, right? So for a 1 unit, oh gosh, I can't read. For a 1 unit run, fall 150 units. This is the way I think about these. You don't have to think in quite these words, right? But the concept should be the same. 1 unit over gets you 150 units down. Cool. Okay, and then what's this plus 300 for?
The Y.
That's the y-intercept. So this hits y-axis at 300. Right? So if I want to graph this thing, I'd say, okay. And this is maybe going to be a time when we have to adjust our scales, right? You see why I'm going to have to adjust my scale? Yeah, if I do my usual scale, 300 will be, what, 10 or 12 feet through the ceiling? So let's make a different scale.
Hundreds.
I'm going to go with 300s. You guys can do whatever you want. Make whatever scale you like that'll work. I would advise for something like this. Basically, I'm just drawing the picture I would normally draw, and then I'm relabeling it, right? So if I start at 300, what goes with 1 unit over?
Oh, 150 also apply?
So here's my dot where I hit the y-axis, right? I just read that off the intercept. You guys see that? That's literally just this piece of information being translated. Okay, now I want to know about the next dot. And once I've got the next dot, I can draw the line, right? So if I go over 1 unit in the x, so maybe here's 1 unit in the x, what goes above that? Yeah, I should go up to 150. It is negative.
It's a negative.
I went over 1 unit, right, in the x, and I was here. I dropped 150 units in the y.
So basically, the minus here is only for the kind of graph is gonna be either positive or negative.
Yeah,
Okay.
yeah, the minus really just affects whether the slope is positive or negative. If it was a positive 150, in the 1 unit over, I would go up to 450, right? See that? Another option is you could plug some number in here, right? So this is really the point 1 comma f of 1, right? And we get straightened out that f of 1 is in fact 150. So once I've got this, I draw my line. Oop, wow, that's not gonna work. Lines should be straight, right? Okay, so there's my line. Now I can play the same game that I could play with problem 13. If I don't want to go to this trouble, we really don't have to. You want to see it without the picture?
That's what I thought we were supposed to do.
Okay, so let's see it without the picture. I would prefer it if you could think both ways, but drawing the picture is a good default. Okay, so without the picture, what's the slope? So the slope is negative 150 or negative 150 over 1, right? I don't care which one you write. I think this fairly often. All right, how about B? What's the x-intercept?
300.
Okay, so which one of these do I know from looking at the graph? Do I know the x or the y?
Y.
I know the y-intercept is y is 300, or the point that goes with that is 0, comma 300, right? So that's the y-intercept. What's the x-intercept?
2. X equals 2.
Okay, so what do I want to know? I want to know the x-intercept, right, is when f of x is 0. So if I set this thing equal to 0, so my scratch word for this would be, okay, I've got 150, negative 150x plus 300, set this equal to 0. And now we can solve, right? So we get minus 150, x is minus 300. So x is negative 300 over negative 150, which is negative 1 over negative 1 times 2 over 1 times 150 over 150. I don't know if this is the way you guys think. So the other way to think, right, is a negative over a negative is a positive. That's this piece. Then 150 goes into 300 twice, right? That's that piece. Yep. I'm just kind of illustrating the canceling here. We're going to do some stuff with factoring and canceling later today, and I want to have that in our heads.
And we want to leave that as 2 over 1 or 2?
Either way. I would probably write it as x equals 2. Or, what's the point version of this thing? 2 comma 0. How do I know it's 0?
Because it's an intercept.
Yeah, because it's an intercept, and because that's what I started doing, right? I set the output equal to 0 and solve. You see that? Okay, so that gets us through those. How about D? What's the domain of this thing? R. How do you know? Okay, so there are a couple ways to think here. One, you know this because it's a line, and lines have domain of R. That's an option. The other option is to look at it and to say, okay, what x's can't I do this rule to? There aren't any x's I can't do this rule to. I know how to stick x's in this rule, and it always makes sense. Right, I'm looking for like, oh, is there a spot where I can take the square root of a negative, or is there a spot where I can divide by 0, or some other forbidden math thing, right? So far we really just have the 2, right? There isn't even division in here. There isn't a square root, so I think I'm okay. You see that? Okay, so that gets me R. How about the range? That'll still be R. You need to be a little careful with this. Which lines don't have range R? Flat lines don't have range R. So I know this line is not flat because it has a slope of negative 150, right? Not 0 specifically. Yeah, by flat I mean constant, or m is 0. All right, so that's got my range. Okay, so F and G are positive and negative, right? How do I find out positive and negative?
Use the intercepts.
Yeah, okay, so I should find the 0. The 0 is 2, right? I already did that. So that means my world looks like this, right? Here are my x's. And here at 2, I know that the output is 0, right? So on one side of that, it's either positive or negative, and on the other side, it's either positive or negative. So I can pick, say, a test point in here, and just plug it in the function. So my test point on this side might be 0. So then I ask, okay, what's f of 0? F of 0 is 300, which is positive. So over here, we're all positive. You see that I didn't have to draw the picture for it. I just kind of, oh, well, the only spot it can change is when it goes through 0, right? So it must be either positive or negative for all of this, and must be either positive or negative for all of that. So over here, I plug in something, I get a positive. That means it's got to be positive on the whole bit. Okay, see that? What's the easiest number right of 2 to test?
3.
Probably 3. Okay, so if I test 3, I'm looking for what's f of 3, right? F of 3 is, plug 3 into this, right? Negative 450 plus 300 is
150.
150, and it's negative. So I get a minus over there. So which x's am I positive on? Negative infinity to 2, right? And I'm negative from at 3, right? But it starts at 2 and goes up. So 2 to infinity. You guys see that? Okay. Let's see. How about h and I? When is this thing increasing? When is it decreasing?
Or is that just about the?
Okay, so keep in mind this is just positive and negativeness, right?
Yeah.
I want to look at the line to know about increasing, decreasing. I want to know if the line goes up or down, right?
Is that the one?
This line. Remember, that's problem 13. That's a
Right,
different
okay.
graph. So we were doing this without a graph, right? So we want to know, does this line go up or down? This line goes down because the slope is negative. So h is decreasing on, when is this thing decreasing? All the time, right? When is it increasing?
You can just determine that by looking at the slope, right?
Yep, the slope's negative, so it's clearly not increasing. It's got to be decreasing. It's decreasing at the same rate everywhere too, right? So 1 unit over gets me minus 150 units. Other things that aren't lines don't have that constant increasing or decreasing. They may be increase or decrease at different rates, right? Okay, see that? Okay, other things? All right, let's take our 5-minute break, and then we'll talk about, no, we're not going to talk about 8.6.